The first question that we have to answer is, how do we heat up? And the answer to that question is we heat up two ways. We heat up from the outside, meaning the things that we come into contact with, the clothing that we put on our body, whether or not there's heat in the room or whether or not it's cold outside or cold in a room. And we heat up from the inside. Our body has the capacity to generate more heat or to cool down, meaning to turn off the heating process. And it can do that in ways that match the external environment. The simplest way to think about this is that we actually have two body temperatures. People will say, oh, what's body temperature? 98.6. That's actually not true. Body temperature varies between individuals. It varies across time of day within individuals. And at every point across your entire lifespan, you have two distinct temperatures. One is the temperature on your skin, what scientists call your shell, and the temperature of your core, your viscera, meaning your organs, your nervous system, and your spinal cord. And as you can imagine, the temperature of your core is always higher than the temperature at your surface. So the important thing to know is that you have a temperature at your shell and a temperature at your core. Now, you don't need to know exactly what those temperatures are in most cases, but it is vitally important to understand that you have those two temperatures and that your brain is constantly sending out signals to your body as to whether or not it should heat up or cool down depending on the temperature of the shell. Your brain has neurons that send signals to other cells in your body and deploy the release of chemicals in your brain and body to heat you up when you are too cold and to cool you down when you are too hot. If I were to throw a cold towel, ice cold towel onto your torso right now and ask you, well, how do you feel? You'd say, oh, that's cold, that's chilly. However, because your brain is acting like a bit of a thermostat, as the surface, the shell of your body felt cool, it would make sense that that thermostat would activate biological mechanisms that would heat up your core. Similarly, if I were to put you into a very hot environment, you'd say, oh, wow, it's really, really warm in here, but your brain and your body would go through a lot of effort to activate mechanisms to cool you down. So anytime we're talking about heat, meaning deliberate heat exposure, things like sauna, it's very important to understand not just the stimulus, how hot something is, how long you're in a sauna, etc., but the effect that has on your shell and on your core. If you can understand that, you can design protocols that are literally perfect for your goals. And as a final point about this, if you want to develop the best tools leveraging heat for your biology and health and performance, you want to understand heat as a process, as a verb, as heating, not just heat. Because there's the temperature that you are at before you encounter the heat stimulus, before you get in the sauna, for instance, during the heat stimulus, so while you're in the sauna, and then afterward. Everything in biology is a process. So as you'll soon learn, there is a specific sauna protocol that can allow anybody, in fact, to increase the amount of growth hormone released into their brain and body 16-fold. That's right, 16-fold. However, it involves shifting from a hot environment to a cool environment to a hot environment to a cool environment over and over and over again over a very short period of time.
Annotated and summarized, easy to share with loved ones. The description below the title for this video has these summary points.